Today I will start about the chapter with aldehyde, ketone and carboxylic acid, that is carbonyl compounds. This slide showing that the first one is aldehyde RCHO, second one is ketone RR-CO, third one is carboxylic acid RCOH, and next one is acyl halide RCOX, amide RCONH2, ester RCOOR, and acid anhydride RCOOCOR dash. Three examples of aromatic aldehyde are given here: vanillin, salicylaldehyde, and third one is cinnamaldehyde. Common names here: first one is acetaldehyde, second one is benzaldehyde, third one is beta bromo benzaldehyde or beta bromo butyrialdehyde, or it can be called as 3-bromo-butanol. Next one is acetone, CH3COCH3, acetophenone, propiophenone, benzophenone. Next, ethanol, 4-bromo-3-methylpentanol, methyl cyclopentanone, cyclohexane carbaldehyde. Next one is pent-2-enal and 1-propanol. This is a table for various types of aldehydes and ketones and with their common name and equate name. ACHO is formaldehyde, CH3CHO acetaldehyde, third one is isobutylaldehyde, fourth one is gamma methyl cyclohexanal carbaldehyde. Here this is phthalaldehyde, this is metabromobenzaldehyde. These are some ketones, and this is the table of the equate name. This is the structure of the carbonyl compound, carbonyl group. Here the carbon is sp2 hybridized, having a sigma bond and a pi bond over a CO bond. The pi bond can be represented like this. It is suggesting that the mesomeric structures suggesting that the carbon atom in the carbonyl group is electrophilic. So here this carbon is nucleophilic. So here nucleophilic addition reaction will occur in this CO group. Preparation of aldehyde. It can be prepared by oxidation of alcohol, by dehydrogenation of alcohol from hydrocarbons. We can do it by ozonolysis of alkene, by hydration of alkyne, etc. First one is here benzoyl chloride. If we give H2PDBASO4, it will produce benzaldehyde. Then if we give RCN, that is nitrile in presence of essential to HCl, which is called Stephen's reaction. After hydrolysis, the product is RCHO. RCN in presence of aluminum isobutylate. Aluminum diisobutyl hydride or dival H. It is called dival H. So RCN will be converted into RCHO. If we give dival H to this nitrile group, it will form aldehyde, retaining the double bond. Similarly, the esters are also can be reduced to dival H or lithium aluminum hydride. If we reduce the ester with lithium aluminum hydride, it will produce alcohol as a product. If we give dival H, then ester will be partially reduced to aldehyde. Now by oxidation of toluene, it will give benzaldehyde in presence of CrO to Cl2 in CH2 as a solvent. It is called the Etard reaction. Then CrO3 in presence of acetic anhydride, it will also produce benzaldehyde after hydrolysis of this intermediate. By side chain reaction, if we give chlorine here in presence of H2, chlorine will and 1 mole of chlorine will substitute 2 hydrogen here. It will form benzal chloride. It will after hydrolysis, it will give benzal aldehyde. We can produce aromatic aldehyde by Gattermann-Koch reaction by giving benzene in presence of COHCl, anhydride ClCl3 or CuCl. It will form benzaldehyde. With the reaction with Grignard reagent, the nitrile group will be converted into ketone compound. Next one, benzene with air COCl in presence of AlCl3, which is Friedel-Crafts acylation reaction. It will form ketone. Physical properties. Boiling point, methanol is gas at room temperature, ethanol is volatile liquid. Other aldehyde ketones are liquid or solid at room temperature. The boiling point of the aldehyde ketone are higher than that of hydrocarbons and ethers as compared to the molecular masses. It is due to the weak molecular association of aldehyde and ketone arising out of the dipole-dipole interaction. Also, their boiling points are lower than that of alcohol, similar to molecular masses due to the absence of intermolecular hydrogen bonding. Here the table of the boiling point is given: N-butane 273, methoxyethane 281, propanol 322, acetone 329 and propanol 370. So it is suggesting that the alcohol has highest boiling point. However, the solubility of aldehyde and ketone decreases rapidly on increasing the length of the alkyl chain. All the aldehyde and ketones are fairly soluble in organic solvent like benzene and ether and methanol or chloroform, etc. Lower aldehyde have sharp pungent odor. The size of the molecule increases. The odor becomes less pungent and more fragrant. In fact, many naturally occurring aldehyde and more fragrant flavoring agent. Nucleophilic addition reaction. Contrary to electrophilic addition reaction observed in the alkene and the aldehyde and ketone undergo nucleophilic reaction. The mechanism of the nucleophilic addition reaction occurs through this type. It is a planar molecule. Nucleophilic addition occurs from this side or from this side, so it will give a receiving mixture of the product if it is a prochiral center. Now here carbonyl compound, water addition reaction does not take place, but HCl addition reaction takes place. This will form the cyanohydrin. Sodium thiosulfate addition can occur here. HCl gas cannot do addition reaction, but hemiacetal and acetal formation reaction can occur here. Here cyclic ketal can form with this ketonic compound. NH2 Z type reaction can occur in ketonic compound by release of one molecule of water during the course of reaction. Z is alkyl aryl OH NH2, C6H5ONH, NHCO, NH, etc. This is the list of the Z reagent. When Z is equal to H, that is ammonia. This is the product imine. When amine is given, substituted imine. When hydroxylamine given, this is oxime product. When hydrogen is given, this is hydrazone product. Phenyl hydrogen is given, so phenyl hydrazone will be product. 2,4-dinitrophenyl hydrogen while given, 2,4-dinitrophenyl hydrazone as product. And when semicarbazide is given, it will give semicarbazone as a product. This is reduction. Two types of reduction can occur of the carbonyl compound. One, it can be converted into alcohol, or it can be converted into hydrocarbons. So reduction of alcohol can be done with lithium aluminum hydride or sodium borohydride, and reduction of hydrocarbons can be done with Clemenson reduction, where the reagent is zinc HgAcl, and Ullkishner reduction. Here first we use hydrazine to form a hydrazone product, then KOH ethylene glycol to give the Ullkishner reduction. Then oxidation reaction, RCHO can be oxidized to RCOH, ketones can be oxidized to RCOH with the breakage of the bond. Now come to taste of aldehyde and ketone. Aldehyde can give response to tolerance test. It is the tolerance reagent 2Ag NH3 plus in presence of OH minus. After reaction, the aldehyde is converted into RCOH with the liberation of Ag on the surface of the test tube. This is called silver mirror test of aldehyde. Fillings test comprises of the two solutions, filling A and filling B. Filling A contains copper sulfate, and filling B contains alkaline sodium potassium tartarate. These two sodium are mixed in equal amount on heating an aldehyde with the fillings reagent. The reddish brown precipitate is obtained, which suggesting that this is an aldehyde. Oxidation of the methyl ketone will give haloform reaction, will produce haloform. It is the ketomethyl group. The ketomethyl group will give haloform reaction in presence of NaOCl or Cl2 in water or chlorine water or bleaching powder, it can produce haloform. If we want to produce iodoform, we should give I2NaOH. The acidity of the alpha hydrogen. The alpha hydrogen is acid in presence of base, strong base. So now come to aldol condensation. Two molecules of ethanol having alpha hydrogen condenses into butanol or butanol through aldol condensation. Two molecules readily combines with each other, first give an aldol, then the aldol condensation product as alpha beta unsaturated product. Barium hydroxide with ketone will also give aldol condensation product with ketone. 4-methyl pent 3-in-2-one. The reaction occurs through the formation of the enolate anion. It is the cross aldol condensation. The cross product, the concentration of the cross product will be higher. This is the major product. So how many products can form here? 1, 2, 3. 3 products can form here through cross aldol reaction. Here also can occur cross aldol reaction. This alpha beta unsaturated ketone will be the product. Other reaction, Cannizzaro reaction. These are the condensation reaction of aldehyde having no alpha hydrogen. That is, if we take 2 moles of formaldehyde and give 50% NaOH solution, it will produce one molecule of potassium formate and 1 molecule of methanol here. If we give benzaldehyde in presence of concentrated NaOH, it will form 1 molecule of benzyl alcohol and 1 molecule of sodium benzoate. The electrophilic substitution reaction here, during nitration with HNO3 H2SO4, it will give as a meta product of the nitration product, meta nitrobenzaldehyde. Now come to nomenclature of the carboxylic acid. First one is formic acid or methanoic acid, second one is acetic acid or ethanoic acid, third one is propanoic acid, butyric acid or butanoic acid. This is, and COOH is oxalic acid, Ohm's gap. This is called Ohm's gap. Oxalic acid, malonic acid, succinic acid, glutaric acid, adipic acid with the continued addition of 1 CH2 group here. Ohm's gap. Benzoic acid, this is phenylacetic acid, this is phthalic acid. Structure of the carboxylic acid. The carbon here is sp2 hybridized. The acidic property arises due to the lability of the proton from this wedge group and due to the stability of the carboxylate anion as conjugate base. Methods of preparation. We can prepare it by oxidation of alcohol, oxidation of alkyl group. Like first one is converted into carboxylic acid with alkaline KMnO4. If we give CrO3H2SO4, that is Jones reagent, it will be converted into 1 decanol converted into decanoic acid. KMnO4 KOH heat. The toluene will give the potassium salt of benzoic acid, and if you give H2O+, it will give benzoic acid. And the branching compound, branching aromatic compound will also give the benzoic acid. Nitrile compound after hydrolysis. Nitrile compound after hydrolysis will give first amide, then carboxylic acid with the release of ammonia. Amide after hydrolysis will give carboxylic acid with the release of ammonia. Benzamide after hydrolysis with acid will give benzoic acid after release of ammonia. RMGX, Grignard reagent, when reacted with carbon dioxide, it will give carboxylic acid. RCOCl after hydrolysis will give RCOOH. Anhydride after hydrolysis will give carboxylic acid. Ester after hydrolysis will give carboxylic acid. First one here given the Jones reagent, CrO3 H2SO4, it will give butanoic acid. Benzyl alcohol with HBr will form benzyl bromide. When we will give KCl, cyanide addition, and after hydrolysis of cyanide it will give carboxylic acid. So it is called step up reaction. So from benzyl alcohol we can find the phenyl cyanic acid, etc. 3-nitrobromobenzene in presence of magnesium ether will be converted into Grignard reagent, and with the reaction with carbon dioxide and after hydrolysis it will give 3-nitrobenzoic acid. KMnO4 here will oxidize the alkene group first into dialcohol, then dialcohol will be oxidized into dicarboxylic acid. It is atopic acid. Butanol in presence of ammoniacal AgNO3, which is Tollens reagent, it will be converted into butanoic acid, ammoniacal AgNO3. Physical properties. Aliphatic carboxylic acid up to 9 carbon atoms are colorless liquid at room temperature with unpleasant water. Higher acids are wax-like solid and practically odorless due to their low volatility. Carboxylic acids are higher in boiling liquids than aldehyde and ketone. Some of the carboxylic acids are solid due to the formation of the strong intermolecular hydrogen bonding. The carboxylic acids compound absorb water due to the formation of the strong hydrogen bonding among the molecules. Benzoic acid is simplest aromatic carboxylic acid, nearly insoluble in cold water. Carboxylic acids are soluble in less polar organic solvent like benzene, ether, alcohol, chloroform, etc. Reactivity. Carboxylic acid, when reacted with sodium metal, it will form sodium carboxylate with the release of hydrogen. NaOH, it will form sodium carboxylate. NaCO3, it will form sodium carboxylate with the release of carbon dioxide. Carboxylic acid dissociate in water to give resonance stabilized carboxylic 8 anion and hydronium ion RCOO minus, which is a weak RCOOH is a weak acid, but its conjugate base is strong base. Effect of substituent on the acidity and basicity. Electron withdrawing group will increase its acidity. Electron donating group will decrease its acidity. Direct attachment of groups such as phenyl or vinyl group on the carboxylic acid increases the acidity on the corresponding carboxylic acid, contrary to the decrease in the expected due to the resonance effect shown in the below. This is because greater electronegativity of the sp2 hybridized carbon to which the carboxyl carbon is attached. The presence of the carbon withdrawing the carbon phenyl group this decrease in the acidity. So 4-nitrobenzoic acid has much higher acidity than benzoic acid, then 4-methoxybenzoic acid. The pKa value shows it. pKa value is 3.41 for 4-nitrobenzoic acid, pKa value is 4.19 for benzoic acid and 4.46 for 4-methoxybenzoic acid. The effect of the following groups in the increasing acidity order is phenyl less than iodide, less than bromide, less than fluoride, less than fluoride, less than cyanide, less than NO2, less than CF3. CF3COOH has higher acidity than CCl3, then CaCl2, then NO2, then this increasing acidity order. FCl, Br, formic acid. Formic acid has higher acidity than this. Esterification reaction. Carboxylic acid with alcohol in presence of concentrated sulfuric acid will form ester, sweet smelling ester. This is the mechanism of the esterification reaction. Reaction with PCl5. PCl3 SOCl2. All will give RCOCl as a major product. With ammonia, it will first form ammonium acetate as a salt, then after heating it will form acetamide, and after further heating in presence of P2O5, acetamide will give acetonitrile CH3Cl. Same as well as benzamide can be formed. This is phthalic acid, this is phthalimide. This is thalalimide. This is thalalimide and this is phthalimide after strong heating. Now reduction. Carboxylic acids are reduced to primary alcohol with lithium aluminum hydride or B2H6, and HCO plus will give alcohol. Carboxylic acid decarboxylation reaction with soda lime NaOH will give RH alkane as a product. Halogenation reaction, if we give halogen X2 in presence of red phosphorus, then give water, it will give alpha halo carboxylic acid. Ring substitution, nitration, it will give metanitrobenzoic acid, bromination, metabromobenzoic acid. Thank you. This is the end of this chapter.